Hi, I'm James Mora, Senior Editor at Electronic Design. Today, we're diving into the shift to software-defined vehicles, and the concept is all about enabling continuous updates and maybe even more importantly, upgrades to the vehicle's software over time. But decoupling all that software from the underlying hardware requires a complete rethinking of the car's internal architecture. Take Ford, for instance. Last month, the company unveiled a new universal EV platform, one part of a broader strategy to stay competitive with the Teslas and the Rivians of the world. To underpin the platform, executives said it is developing a new zonal architecture from the ground up. So instead of grouping all the hardware in the vehicle by function, Ford and other automakers are moving to a new model in which all the hardware, the sensors, the processors are clustered into physical zones throughout the vehicle, hence the term zonal architecture. So according to Ford, the approach not only gives it the ability to add new features, but it also eliminates close to a mile, around 4,000 feet of wiring compared to the previous generation. So despite these and other advantages, the shift to zonal architectures is not easy. While it helps reduce system complexity, it adds a lot of engineering complexity and integration challenges on the front end, which ultimately adds to the development cost for automakers. To unpack some of the pros and cons of this new architecture, I'm joined by Bala Mayapurath. He is a vice president and general manager in the automotive business unit at Analog Devices. And specifically, he oversees its gigabit multimedia serial link technology, which could play a key role in the future of in-car connectivity. Bala, thanks for taking the time to be here. And so to start, can you discuss the main technical differences between a traditional domain-based architecture and a zonal one?
The primary differences between a domain-based architecture and a zonal architecture are that in a domain-based architecture, there are functional domains that are fully integrated with the hardware and the software. An example of that would be, an ADAS domain and an IVI domain. So in the ADAS domain, you would have all the sensors coming in. There'd be a processor that processes the data that's coming in, and all the software would be part of that domain. And there could be a similar IVI domain. Now contrast that with a zonal architecture where essentially the sensor data, for example, just going back to the domain architecture, take that same kind of use case, the sensor data would be aggregated locally. So for example, you may have video coming in, or let's say audio coming in into a certain zone from all the sensors that are in that zone, and then being aggregated and then sent to a central compute, which again receives data from all these different zones. So that's architecturally, that would be the difference. There are ramifications from having a zonal architecture where it greatly simplifies the wiring, because a lot of the wiring becomes local, and then you have an aggregated connection to the central compute. And it also makes the system very scalable compared to a domain architecture where you can, if you want to, for a system that has a lot of sensors coming in, you could have multiple zones versus a simple platform, where you may have just one or two zones. So scalability becomes a lot easier.
If you sort of compared the blueprints of a vehicle based on a domain-based architecture and a zonal architecture, so the domain architecture, there would be a lot more compute units maybe spread around the car, whereas in the zonal architecture, you maybe have, them clustered in different corners. I think, for instance, Rivian, which uses a zonal architecture, they call their zones north, south, east, and west, or maybe they only have three directions, but they sort of name the zones that way. So is that sort of a good way to think about how this would look if you sort of like were able to look inside the vehicle?
Yes, exactly. You can have essentially the way to think about it is aggregation of incoming data to the vehicle and control in different physically in different regions of the car. And then from there, a higher bandwidth connection to a central compute, where now all the compute is going to be localized, right? So you can think of a scenario where in a domain-based architecture, you could have multiple, a distributed control and compute architecture, while here the biggest chunk of the compute is in the central box, with the zones doing some level of edge compute and control.
Hmm. Okay. So we started sort of with the what of zonal, but I wanted to get into the why too. Um, sort of what's driving this transition from the more traditional domain to the newer zonal architecture? What sort of drawbacks exist with the domain architecture that don't really fit with what automakers want to do?
Yeah. So James, maybe what I do is let me abstract this one level up, right? So
Okay.
if you think about what's driving this whole thing, it's basically what the consumer wants. The consumer is looking for a an experience with essentially a digital platform, right? So some of the bigger mega trends in the automotive industry, if you think about that, there's a ADAS and autonomous driving is a big one, right?
Hmm.
Another one could be a very interactive user interface, right? And that user interface, if you dig into that a little bit more, it could mean um, automatic headlights that change their direction when there's a car approaching, right? Or an infotainment platform that essentially understands the needs of the driver and adjusts the settings in the car, the mood, the music, whatever. Um, Autonomous driving, if you look at that paradigm, that's about being able to drive either with your hand on the wheel or completely hands off, like a level 3 autonomous driving. So if you think about these functions that the consumer wants, they are primarily software driven functions, right? So software is starting to become a really important part of the vehicle itself. And then when you go to the next step and say, how do you implement a software defined platform, and what does that mean? Well, for the consumer, what it means is they want to be always connected. They want over-the-air updates so that their car is up to speed on all the latest software improvements. And from an OEM perspective, they're looking for a digital platform that essentially allows them to do this, right? So they need a platform where the software can be modified over time, uh, and you can make changes in the underlying hardware, and that is not visible to the software. So there's some separation between the hardware and the software through some abstraction.
Hmm.
And so they want to implement that kind of a digital platform. And now when you say, okay, that's what you need, then the question is, what kind of hardware architecture is amenable to this kind of a digital implementation? That's where the zonal architecture becomes really critical, because it's a scalable platform. It greatly reduces the complexity of what's out today. So
Hmm.
that's a simple, scalable platform where a lot of the compute is now centralized. So it's fewer number of ECUs. A lot of the control functions can be localized, and a lot of the aggregation of incoming data can be localized. So the architecture that we have, the advantages of the architecture that we get with the zonal essentially translate back to a quicker implementation of these functions that are essentially driven by the megatrends. Does that
Hmm.
make sense?
Hmm. Yeah, it does. So you went through a lot of the advantages of the new architecture, but I wanted to ask a little bit about the challenges, because it seems that there are a lot of them. Just despite a lot of the significant investment that's going into software-defined vehicles, it seems as though a lot of traditional automakers are struggling with this shift, or at least they're struggling a little bit more than, say, the Teslas or the Rivians, or the BYDs of the world that have sort of been working on these architectures from the start.
Right, right.
So I'm just wondering, from where you stand, what some of the big challenges you see? What are engineers sort of grappling with?
Right. So, like you said, there are two categories of OEMs. There are OEMs who are getting into this with a clean slate.
Hmm.
They have an opportunity to start designing an architecture um, with no backward compatibility requirements, right? So there you can pretty much start with a very optimal architecture. The challenge that the traditional OEMs face is that they have vehicles on the road today with a domain-based architecture that somehow they need to be able to support when they transition to STV. So the full hardware architecture that they're beginning with is not the most optimum architecture that a new company would start with. So now they have to worry about, transitioning from a domain base to a zonal architecture in steps, and then
Hmm.
trying to manage the software across these domains to run in this fashion, right? So that is definitely one of the challenges. Even for an OEM that's starting with a clean sheet of paper and going straight to a zonal architecture, none of these designs have been implemented fully so far, or they're still in the process of getting implemented. So, for example, how much power is required in a central compute? Now that you have all the processing in the central compute, and you want to say have a level 3 autonomous drive system. So the amount of power consumption in that central compute is huge. So you need to worry about thermals and how do you manage that. There's aggregation of say data in the zone. How much bandwidth do you need to transport that to central compute, and then with minimum latency send out control signals. So a lot of that is still new, and the biggest challenge, in my opinion, is this hardware abstraction. That's an interesting concept, but in reality, I would think much harder to implement because you're essentially saying that the application layer, let's say it's a surround view as an example, right? And you should be able to say, okay, turn on surround view, independent of what's in the hardware layer. This should work seamlessly. That requires close cooperation between the companies that are designing the hardware, the software, and everything in the middle. So there's a lot of new procedures and processes required to make all this work, even for a brand new system, right? That's being designed from scratch. So I think a lot of it has to do with those things. Um, so those are the two different categories of OEMs and the problems they face.
Hmm. Right. So when I was thinking about asking that question, I almost added to the end, like, would you say, the challenges are primarily, hardware related or software related? And I know it's never that simple. It's always a combination. But
Yeah,
it seems to be, with the case of more traditional automakers, just porting over all that software and making sure it all plays nice together. That,
correct.
from your perspective, seems to be the big
Yeah,
challenge.
yeah.
I'm wondering, do you have to sort of over design the hardware or even the network that connects all of these different building blocks together? Do you have to over design all that to accommodate what's coming down the pipeline, potentially years out?
Right. It depends on the hardware, James. That's how I look at it. So again, let's
Okay.
let's take a concrete example, right? Let's say we are talking about ADAS system, right? Keep going back to that because it's a little bit more concrete.
Hmm.
And let's say you have a level 2 plus system, which means on the road you have to have your hands on the wheel, but the car will pretty much drive by itself. Then you want to move. So that requires cameras of certain resolutions placed in certain positions around your car. It may also require some radar and potentially maybe not LiDAR, right? Now you want to move to a level 3 system, right? So that may require, let's say, higher resolution cameras, right? So,
Hmm.
so there you don't have a choice. You have to replace the camera. It's hardware. But then from a software perspective, the question is, can you write your software so that the transition from a level 2 to level 3 is very painless, right? Um, right. That means um, all the underlying processing activities should be still be part of the middleware or the drivers that work close to the hardware, so that the change in camera resolutions is not visible at the application layer. From a hardware perspective, again, depending on which piece of the technology you're thinking about, that would need to change. From an application layer, probably not. Now let's think about the connectivity. You're absolutely right. We want to be able to provide connectivity that handles the higher resolution cameras as well as anything that's below that, right? So we got to look at the maximum use case and provide that bandwidth, because replacing cables is not going to be easy to do, or replacing connectivity ICs.
Mhm.
So yes, some parts of the design some parts of the architecture are over designed.
How you see sort of this shift sort of impacting, I guess, the supply chain, or impacting, how companies like ADI interact
Mm-hmm.
with automakers, how the relationships that have been formed over, decades in the auto industry are sort of changing.
Mm-hmm. Mm-hmm. Yeah, that's a really good question, James. And we are ourselves starting to explore this in more detail.
Hmm.
Um, think about it this way, right? Today, ADI provides a lot of critical technologies into a vehicle. So we are the leaders in edge connectivity. So we have video, audio connectivity, and 10 base T1S type connectivity for control functions, right? We also do audio processing. We provide power solutions. So the question that we ask ourselves is, is taking let's just take the video connective. I'm sorry, the connectivity piece of it.
Hmm.
Um, is there a software or a middleware solution that ADI can provide along with all these connectivity solutions that bridges the gap between the end application software and the hardware layer, right? So is there a play for a company like ADI to essentially move up the stack and provide some of the key drivers that are essentially like an API that allows control of all the ADI technologies, right? Um, this is something that we are investigating. We're having discussions with OEMs and other partners to see where the value is. Um, and so to answer your question, how will this ecosystem evolve? We think that there is a play for a traditional semiconductor supplier to move up the stack. And at the same time, there might be more new players coming in into the software space who also have go down the stack into the middleware.